Mr. B. Dhanasega is working as a lecturer in Department of Information Technology, Anna University, Chennai. He finished his MCA from Urumu Dhanalakshmi College, Bharatidasan University. He finished his ME in Computer Science and Engineering from College of Engineering, Anna University. His areas of interest are multi-core programming and architecture, programming models, compiler, automata theory, cryptography, and algorithms. He is an expertise in subjects like compiler design, formal languages and automata theory, analysis of algorithms. His research area is code generation for multi-core architecture.
Welcome to the UGC lecture series on computer science, and here we are having the subject called theory of computation. So, let me start with the recap of what we had seen as far as the previous lecture is concerned. So, in the previous lecture, as far as the context free grammar is concerned, it is capable of generating any context free language, and similarly the push down automata is also going to be a device that is capable of recognizing any context free language. But how the language will be derived is differing as far as the CFG and even the PDAs are concerned. So, CFG it is using the sequence of derivations for deriving the language, whereas in the case of the push down automata it is capable of deriving the language, but with the help of instantaneous descriptions. So, how the IDs are defined and how the strings are derived with the help of the sequence of IDs. So, those things we had seen as far as the previous lecture is concerned. In addition with that, we have seen that as the two different ways of recognizing the languages by PDAs. So, it is like we can have even the recognition with the help of the final state or with the help of even empty stack also. But even if you are going for recognizing the language with the help of final states or with the help of empty stack, the class of language recognized by these two kind of recognitions are going to be still same, that is nothing but the context free language. So, when you find that these two ways of recognizing the languages are equivalent, so there should be some kind of conversion possible from the PDA recognizing the language using null stack to the PDA recognizing the language using final state. Similarly, given a PDA which is capable of recognizing the language using final state, so that should also be converted into a PDA recognizing the same language, but with the help of empty stack. So, these two must be equivalent, then only we can claim that the language recognized by the PDA, whether it is going to be final state recognition or it is going to be empty stack recognition, it will be same and it is nothing but the context free language. So, these two topics actually we are going to have as far as this episode is concerned. So, the first one is the conversion from PDA accepting the language using null stack to the PDA accepting the same class of language using final state. So, given a push down automata which is capable of recognizing the language using the empty stack. So, in the case of empty stack, the final state is not significant. So, it is not at all there as far as the language recognition with the help of empty stack is concerned. But whereas in the case of the language recognition with the help of final state, it is strictly required to have the final state, because irrespective of whatever be the content available on the stack, we will say whether the language is accepted or not only by seeing whether we are in the final state of the push down automata along with nothing else on the buffer. So, that is what the conversion from your PN, that is the null stack push down automata, to the final state, that is push down automata. The next one is simply the reverse. Given a push down automata which is capable of recognizing the language using final state, then how do you convert it into a push down automata capable of recognizing the same language with the help of empty stack? So, let me start with the first conversion. So, here we have the conversion from Pn to Pf. So, first of all we should define the various components of the push down automata, that is recognizing the language using null stack. So, there are actually 7 components. Out of the 7 components, since it is going to be Pn, that is language recognition by null stack, the final state is not important. So, if you are given any push down automata with only 6 components, immediately we can claim that it is a push down automata recognizing the language using null stack. But whereas in this case, even you can find out the entire 7 number of components, but where this f is always going to be empty because it is not going to be of importance. So now it is required to find out the equivalent push down automata, but it is going to recognize the language using final state. So the conversion is, as far as the given automata is concerned, we do not have a concept of final state, but in the resulting automata the language should be declared accepted or recognized only after reaching the final state. So there is a need for introducing a new final state, because of there is a need for having a final state as far as the PF is concerned, that is push down automata capable of recognizing the final state is concerned. And similarly, we want to have a new starting state with its own initial configuration. So as far as the PF is concerned, that is push down automata capable of recognizing the final state is concerned, we must have a new starting state and a new final state. Other than that, it is actually simulating the complete behavior of the push down automata with, that is, empty stack recognition. So every transition available in the push down automata which is accepting the language using empty stack will be there even in the new automata are concerned. And in addition with that, we will be having two new states, and the transitions from the initial state to the initial state of the given push down automata, and the transitions from the final configuration of the push down automata, that is a given push down automata, to the final state of the new push down automata, they all should be rewritten so that, or it should be included so that we will be having a new push down automata which is capable of recognizing the language using final state. So the components are here actually explained. First one we are having, that is your Q, that is the entire set of states available even in your Pn also, that is a given. In addition with that, as I told you, that is two new states. So P naught will be considered as the starting state, and Pf is supposed to be the final state of the new automata. So the total number of states available in Pf, that is PDA accepting the language using final state is concerned, it is going to be Q union P0 and Pf. The second component, it is same as whatever the second component available in the given push down automata. It is because of any change on the input alphabet will make some change on the language. Here the constraint is the language should not be changed. So there is no question of having a different alphabet as far as the PDA, whether it is in Pn form or in Pf form. So the next is what is going to be the stack alphabet. As far as stack alphabet is concerned, every symbol available in the stack alphabet of given PDA, in addition with that we need x naught, actually this will be considered as the starting stack symbol for the Pf. Already there is a starting stack symbol for Pn, that is z naught. So over that we will be pushing, that is for x naught, so we will be having that x naught in addition with that z naught. So that is the stack alphabet. Then we have to write the entire set of transitions, that is del f, so it is described just below there. And what is going to be the starting state? It is nothing but P naught, that is a place where we have to start as far as the language recognition by Pf is concerned. Then x naught is the initial stack symbol of Pf, and finally it is going to be what is the final state of the push down automata. As far as the final state of the push down automata in Pn is concerned, it is of no significance, but whereas it is very important to have the final state of the push down automata which is accepting the language using final state. So that is what Pf, which is the newly introduced state as far as Pf is concerned. So now when you are looking at del f, so the first one, you can have this diagram here. So here we see that the Pn is available within this yellow color ellipse, and within that we have some number of states, maybe it is Q naught is one of the states, starting state of Pn, then more number of states are available. So you just take all the transitions available in this Pn as transitions in Pf also. But in addition that we are having P naught as a new starting state, and another one Pf, that is going to be the new final state. So from this starting state, how do we make a jump to the starting state of Pn? So from the starting state, suppose if I am taking, that is the transition like epsilon x naught, we are supposed to have, that is z naught x naught. So the reason why we are having x naught here is that is starting stack symbol for Pf, which is already assumed. Then the entire string is going to be recognized only by Pn. So it means the string should be completely given as input for Pn without any removal of symbols from the string. So, the transition must be defined only for epsilon here. So, we are defining the transition that is for epsilon with x naught, that is the initial stack symbol of Pf on top of the stack. The output is, actually we need to jump into the initial configuration of Pn. The initial stack symbol for Pn is Z0. So, we want to have Z0 on top of the stack, so that the Pn will understand that it is in the initial state when we are having a jump from P0 to Q0. So, the transition which is required for this is described here. So, del f of P0 comma epsilon comma x0 is Q0 comma Z0 x0. We find that Z0 is pushed over x0. So, the next one is, here we can see that we need to make some kind of jumps from the various states available in Pn to Pf. So, we are having transitions from, there is all the states available in Pn to the state that is Pf, but there is a condition. We find that there is nothing in the buffer and we want to have x0 on top of the stack. So, when do we have such a situation is when we find there is no more symbol in the buffer for recognition, that is epsilon, and the stack of Pn is already exhausted or stack of Pn is already emptied. As far as Pn is concerned, if it is having Z on top of the stack, it is initial state. Even if you are removing the Z0 out of the stack, so automatically we can claim that the stack used by this Pn is completely, that is, emptied. So, we will be having epsilon with x0, and now what do you do with the output? You can do anything, because as far as the final state recognition is concerned, it is not going to bother at all about the stack. So, whether we are removing this x0 from the stack or we are simply keeping it x0, that is not going to be the question, but as far as these transitions are concerned, we are having that epsilon as output. It means that x0 from top of the stack of Pn is removed when we find there is no input symbol in the buffer. So, that is what the transition is. Epsilon, that is del of Q0 comma epsilon comma x0 is giving you the new state, that is Pf with epsilon as output. But this is to be done for all the states. The reason why we are doing it for all the states is, any state can be, that is, can be capable of that is removing all the symbols from the stack. It is not one particular state. If you have the concept of final state, then there is only one final state or finite number of final states, but here any state can do the emptying of stack. So, either you can find a situation from Q0 with the empty stack, or from this state with the empty stack, or from this state with the empty stack. So, since we do not know exactly what is the state from where the stack will be becoming empty, so we have to introduce the states or transitions from every state in Pn to Pf, but the condition is no input symbol on the buffer, x0 on top of the stack, the output is going to be epsilon. So, that is what even here also added with there is epsilon x0 on top of the stack, just write, that is, remove that x0 from the stack and reach Pf, and here in Pn also epsilon with x0 on top of the stack, and the output is going to be epsilon. So, how do you, that is, find out these transitions? So, here is the last one, that is del f of q comma epsilon comma x0, it contains Pf comma epsilon, but the condition here is for every state q in q, that is, for the entire set of transitions we have to do the copying of or the introduction of new transitions. This del f of q comma epsilon comma x0 is equal to Pf comma epsilon for every state q in q. So, these are the two new additional that is states, the transitions required for the two new additional states. That is, how do you jump from the initial state of the given Pn to the initial state of the Pf, and similarly how do you reach the final state of the Pf from the final configuration of the Pn. So, other than that, what we should do is, that is, make use of every transition available in Pn as transitions of Pf, because once we have made a jump from the initial state of the Pf to the initial state of the Pn, the entire string we are having or we need to recognize is available on the buffer. So, it is required to empty the entire, that is, buffer content only by the transitions available in the position automata which is given for us. So, you copy every transition from Pn as the transitions for Pf and that will give you the complete picture about how this automata or the push automata which is accepting the language using null state is transformed or it converted into this equivalent automata but accepting language using final state. We shall see some examples after a short break. So, welcome back. We have seen the conversion from push down automata accepting the language using final empty stack to the push down automata accepting the same language using final state. So, this could be that is explained with the help of some example. So, here we have a simple example. The language what we are having is the set of all balanced parentheses. So, for every opening bracket there should be an equivalent that is closing bracket, and the order is also very important. We cannot have a closing bracket followed by an opening bracket. So, it should be only the opening bracket, then followed by that we can have a closing bracket. So, this is a very fit language for recognition with the help of empty stack. So, the idea is whenever we find a opening bracket, just push it onto the stack which is available as far as our push down automata is concerned, and when we find that there is a closing bracket available on the input, there is current input position. So, the idea is check whether the top of the stack is having an opening bracket or not. So, with a closing bracket in the current input symbol position and with a opening bracket already on top of the stack, so we understand that there is a pair of parentheses we have understood. Simply we can remove them both from the stack as well as from the buffer. And if there is any differences, like we may either start with the opening, so closing bracket when empty stack is available, or we may find out a closing bracket with no opening bracket, corresponding opening bracket onto the buffer, so in the stack. So, in those kind of situations we will not be having transitions, so we will not be able to proceed further. So, the required transitions are described here. So, you can see that the starting state is Q0 and there is one more state available, that is Q1, and we do not have a dedicated final state because the concept of final state is not there if you find the language is going to be accepted by using empty stack. So, you see that the Q0 is starting state, and the very first transition is with the opening bracket as the current input symbol, is it not on top of the stack. We say that this is the first symbol we are recognizing from the input. Since it is opening bracket, you simply push it onto the stack. So, you will be having closing opening bracket then followed by Z0. The next is what will happen, suppose if you are having more and more number of opening brackets. So, it is going to be the opening bracket is the first symbol, and then we are having the opening bracket which is also available on the top of the stack. So, the idea is we have only opening brackets. So, we must have some record of all these opening brackets. So, for that we need to push the opening bracket which is available on the input. So, we are having opening bracket and opening bracket on top of the stack. The next one is the matching parenthesis. So, the current input symbol available for us is going to be the closing bracket, and the symbol which is available on the top of the stack is an opening bracket. So, now there is a matching set of there is parentheses. So, for an opening bracket available on the top of the stack, we have seen a closing bracket available in the buffer. So, the pair is obtained or a match is obtained. So, simply we can remove them both from the stack as well as from the buffer. So, if you do it so, then the output is going to be epsilon. So, that is you remove it from the top of the stack, remove the opening bracket from the top of the stack. So, this one line of transition is sufficient in order to recognize any that is set of that is balanced parentheses, but still we will be available in Q0. But now the question is, how do you mark the end of the end recognition? That is, when we find that no more symbol available on the buffer, so what we should do is simply that is check whether we have anything in the stack or not. So, here we find opening bracket, there is epsilon, that means no symbol available on the buffer, and Z0, it means no symbol available on the stack. So, the initial top stack symbol is Z0, so no symbol on the stack also. It means either the given string is having exactly 0 number of balanced parentheses, or the set of parentheses available in the given input are all already matched. So, what we should do is just empty the stack. So, for emptying the stack, it is required to remove that Z0 from top of the stack. So, the output is going to be epsilon when epsilon comma Z0 on top of the stack, you just simply leave it. So by the time when we are reaching that is Q1, we will find that no symbol on the buffer and no symbol on the stack. So that is what needed as far as the acceptance by empty stack is concerned. But now the question is how this automata will be converted into an equivalent automata, but the acceptance is with the help of final state rather than the empty stack. So by the procedure, the idea is you just go for introducing a new starting state and introduce a new final state, and define the transitions from the new starting state to the starting state of the given that is automata, that is accepting the language using empty stack. And similarly, from every state available in the transition diagram of the given automata, you add transitions to the new final state, so that when the acceptance is done or when the Pn is accepting the string, we should be able to reach the final state without accepting any more symbol from the buffer. So here is the construction. We find that the starting state is P0, new starting state, and the new final state is P2. So the already existing automata is just marked inside this green color circle. So we find that Q0 and Q1 are the two states. The same transitions are available. Opening bracket Z0, we push it. Opening bracket push. Opening bracket, closing bracket, but opening bracket on top of the stack, you go for a pop. With no symbol on the buffer and no symbol on that is Z0 on top of the stack, you just go for a pop. So in addition with that, we need another that is set of transitions for moving from P0 to Q0 and from Q0 and Q1 to P2, which is considered as the final state of the push down automata. So here the idea is introduce X0, that is the initial stack symbol for P0. So what will happen is you push Z0, that is nothing but the initial stack symbol of the Pn over the stack. So now when you are in Q0, we will be in the initial configuration for the Pn. So it will take care of the emptying of stack after completely processing all the symbols available in the input, and from there you will find that when we find there is no symbol on the buffer and no symbol on the stack used by Pn. The stack used by Pn is starting with Z0 on top of the stack, but it is no more. So we can understand that at this stage there is no symbol available on the stack used by Pn. But still we have one more symbol X0, that is nothing but the initial stack symbol of Pf. So that is whether we are removing that or not is quite a question of the procedure, that is you can either remove that or you can simply keep it as, because we will never bother about what is going to be the content of the stack once we have reached the final state of the configuration or final state of the push down automata. So here we have Q1 epsilon X0 will give you epsilon, so we remove X0, reach P2, and from here also. So this is what situation like when we are having the complete match parameters match. So we will find that X0, epsilon, X0 and epsilon, so you reach P2. So now we have an equivalent, that is automata for the same language. The language is still going to be the set of all balanced parentheses. So we have done the conversion, and we can see that there is the same language is going to be recognized, but the method is only slightly different, except the there is the empty stack and there is acceptance. We accept it with the help of the final state. An equivalent there is conversion is available in the reverse direction also. If you are given a push down automata with the final state acceptance, how will you handle the situation? So how do you convert it into a push down automata accepting the same language, which is accepting with the help of empty stack? So as far as empty stack is concerned, we want to have the stack with 0 symbols. In the case of final state acceptance is concerned, the final state is supposed to be reached, but we do not mind about what do we have in the stack is concerned. A similar kind of approach is even followed here. Let us see the diagram here. So we are given that is Pf, that is the final states are the very important things as far as language recognition is concerned. So if you are in the final state, we can immediately say that the language is accepted. But whereas as far as the conversion for Pn is concerned, then we want to have another two number of states. One is going to be P0, that is the initial stack symbol, then P, that is going to be some dummy state which is required for completely emptying the stack, which is the major requirement as far as Pn is. So the first state, it starts from its own initial configuration. Its initial configuration is P0 epsilon and x naught. So, the reason why we are having that epsilon is, once again we should not disturb the content of the buffer, because that is going to be completely absorbed by this Pf only. So, what we have on x naught is going to be the initial stack symbol of the Pn. So, now the output is, we need to jump onto the first state of the Pf. The initial state of the Pf is marked by having a presence of that x, so z naught, that is nothing but the starting stack symbol of Pf. So, you reach z naught and then over that we are having x naught. So, now we are into that q naught. So, this could be done with the help of the transitions like del n of p0 comma epsilon comma x naught is equal to q0, that is nothing but the starting stack symbol for starting state of the Pn, which is z naught pushing it over the stack with x naught already on the stack. So, that is the first step, and as far as the second step is concerned, you have to find out a jump from every final state to the new state which we have introduced. This is not marked as a final state because the concept of final state is not there as far as Pn is concerned, but still it is required to define transitions from the final state of Pf to the state that is P which is there in Pn. But when do we make a jump from here is, there should not be anything on the buffer. So, the first symbol is going to be epsilon, and we may have anything on the stack, because of the acceptance of Pf will never mind about what is there in the stack. So, this could be anything. Similarly, here also the same story, epsilon y, and the need for this transition is, we have to continuously empty the stack, that is symbol by symbol. So, this y should be removed, and whatever be the number of symbols available just below this y, they all should be removed out of the stack. So, this transition, that is from this final state to this P, it is capable of emptying only one symbol, but there is a chance that we may have even more number of symbols also. So, how do you empty the symbols one by one at a time? So, we will be having a looping statement here or a transition here. We start from P when there is nothing on the buffer, whatever be the symbol available on the stack, top of the stack, we just remove it. So, keep continue this, and this process will continue as long as more symbols are there on the there is the buffer stack. So, where we are going to stop is just by seeing that there is no symbol available on the buffer and no symbol available on the stack. So, that is a place where we will stop, and there is no question of repeating the stop. So, when you are finding that no more valid move, then you can declare that the stack is empty, the buffer is empty, and the language is accepted, or the string whatever is given for us is going to be accepted. So, it could be that is explained with the help of all these transitions. So, the first one is for copying all the transitions from the given Pf to Pn. The second one, so the third, the step number 3 is for that is moving from the final state of the given Pf to the newly introduced state of the Pn. So, there is a final state is q, there is q is in f, and P it is a new state which we have introduced, and from the new state, so what do we do there is, we just repeat it as many times as needed in order to empty the stack. So, we find that del n of p comma epsilon comma that is y, it is going to be p comma epsilon, and you do this for every y that is available in gamma union x naught. So, whatever be the symbol available on the top of the stack, we need not bother about that. We are supposed to remove the entire that is symbol available on the stack. So, if you do it like this, we will be able to convert the given push-in automata which is accepting the language using final state to an equivalent finite automata, push-in automata which is accepting the same language, but using the that is your empty stack. The question is about how we are emptying the stack after accepting the language. So, these are the two conversions which are making use of, or which are enough for proving the language accepted by these two kind of automatas are equivalent. Actually, the equivalent class of language is nothing but the context free language. So, let us summarize that is what we had as far as this lecture is concerned. So, first of all, we have seen that the language accepted by these automata are similar, that is your push-in automata, whether it is going to be by final state or by empty stack, they are going to be similar, and if they are similar, there should be equivalence among the language acceptance by this final state as well as the language acceptance by the empty stack. So, that is what we have shown the equivalence of these two kind of conversions. And as far as the problem set is concerned, first of all, you should know there is what kind of class of language which is accepted by this push in automatas, whether using the final state or using the empty stack. And the next one is about there is the conversion, how we are converting the push in automata recognizing language by using empty stack to the equivalent PDA accepting the same language by using the final state. So, the other question is simply the reverse of that. If you start with final state, so what will happen for the how do we convert it into the PDA accepting the language using empty stack. Then the other one is you may be asked to any kind of construction of push in automata. You may be explicitly asked to construct PDA which is accepting the language either using the final state or using the empty stack. So, if the question is all about empty stack, there is no need of bothering about the final state, but if the question is about the final state, we need not bother about what is there in the stack, but we have to concentrate only on the final state, that is when do we reach. If the string is accepted, we should reach. So, that is about the that is contents as far as this episode is concerned. So, thank you all.